So for section 1, we're looking at the fundamental identities. Now, over the course of this chapter, we're going to evaluate trig functions, simplify them, develop new ones, and solve equations using these. Okay? Because they allow you to change forms from one to another. Now, the ones you're already familiar with, or at least should be, are your reciprocal identities, your quotient identities, and the Pythagorean identities. One which we've dealt with a little bit but haven't actually defined directly are the cofunction ones. These are the fact that cosine is only a pi over 2 rotation off of sine. Same thing with tangent compared to cotangent and secant compared to cosecant. If you just phase shift one over a little bit, you get the same thing. These don't get used often, but when they do, they allow you to shortcut a lot of stuff. Even and odd identities, you should be familiar with those already. If you plug in a negative to anything that's odd, which is sine, cosecant, tangent, and cotangent, it makes the whole thing flip to a negative. Cosine and secant, if you plug in a negative angle, it doesn't matter. It stays whatever the original was. Okay? So, and those are all in the front of the book, top left-hand side, about the top third of a page. Now, for problems, you will have some that are very familiar. For this kind, use the values sine x equals 1/2, and the fact that cosine of x must be greater than 0. To find, apparently they're going to charge them something, to find the values of all 6 trig functions. Okay? Well, they already give me sine. What's an easy one to find once you have sine? Cosecant is probably the easiest because all you do is what? Flip it over. So this is just going to be 2. Since sine is positive, that's also positive. What's another one I can find from sine? Yeah, you can find cosine by doing sine squared plus cosine squared. So if I do sine squared plus cosine squared is equal to 1, that's that main Pythagorean. 1/2 squared plus cosine squared equals 1 gives you 1/4. Subtract the 1/4, you get cosine squared is equal to 3/4. And when you square root that, you're going to get square root of 3 over 2. Now obviously this is a pair that's on the unit circle, so you wouldn't have to go through this in this circumstance. But you will have some times where you're given like sine of x is 7/9. So you can't use the unit circle there. And if it says use the trig identities, this is what you're trying to do. Okay? There's other methods of drawing triangles and stuff like that. Now is that positive or negative though? Positive because it tells you cosine is greater than 0. So that tells you since sine is positive and cosine is positive, what quadrant are all these in? First. So everything's going to be positive. So now that I have cosine, what are the other ones easy? Secant. Secant of x is just going to be 2 square root of 3 over 3. Just flip it and rationalize the denominator. What's left is tangent and cotangent. Now for tangent, sine over cosine. Sine I already have is half. Divided by square root of 3 over 2 is going to be the same as multiplying by 2 over the square root of 3. Yeah. Well, the halves cancel. You get 1 over the square root of 3, which is square root of 3 over 3. So there's your tangent. Lastly is what? Square root of 3. Because just go from this state and flip it over at that point, and you just get square root of 3. There's your 6 trig identities. Those are fairly familiar. They're just trying to get you used to using the identities to manipulate. Okay? What we'll do a lot more this chapter is problems like this, where you have cosine squared x times cosecant x minus cosecant x. And they want you to simplify it. You have a lot of stuff going on there. Okay? And they're trying to get rid of as much of it as possible. There's a few different ways to approach these problems. Okay? And every time I see a plus or minus sign, well, if you look back at those identities we worked with, the only place you have a plus and minus sign between values is the Pythagoreans. Right? So the idea is I want to manipulate this so it looks like those Pythagoreans. Is there any way I can modify what's up there that'll give me those something to do with Pythagorean identities? You can take out what? Cosecant. Greatest common factor. Both terms here, this and this, have a cosecant. If I pull that value out, that leaves me with cosine squared minus 1. And what's cosine squared minus 1 equal to? Sine squared. And cosecant. And sine squared and cosecant. Well, what's cosecant? 1 over sine. Yeah, you have sine squared times 1 over sine. One of the signs is going to cancel off. You're left with sine x. The problem is we did something wrong.
It's probably negative.
Why?
I have no idea. There's no idea.
Whenever I say that, yeah, it's usually something negative sign. And it is in this case. But where's the negative sign come into play? Right. If you actually look at the formula for the Pythagorean, it's sine squared plus cosine squared equals 1. So when you subtract, when you get the sine squared by itself, that's equal to 1 minus cosine squared. Since this is cosine squared minus 1, what do I have to do? Yeah. Take out a negative sign. Basically, this is going to be the opposite. So negative is going to be equal to negative positive. So that's negative sine squared. So that's going to make this negative sine squared, which is going to make this negative sine x. Okay? These problems are not ones where you can honestly just do the ones that are recommended for the quiz the day before the quiz and survive. You will want to practice these. We have work days for this. Make use of them, okay? Questions on that one? But there's little catches like that that can screw you up. Sometimes it helps you out a lot to be able to factor things out because it might allow something to cancel it wouldn't normally the way it's written. Now, if I have 1 minus cosine squared x, yes, that's equal to sine squared x, but I can also factor it instead. There's different ways to change these things. So what would this look like if I factored it?
1 plus cosine of x times 1 minus cosine.
Yeah, this is the difference of two perfect squares. So I can actually just take 1 plus cosine times 1 minus cosine. And that's the same thing. Now the next one, it's kind of easier to see that it's a quadratic, but it can be really annoying to work with because of it. Because I can see 2 times something squared minus 7 times something plus 6. So what I usually do in a circumstance like this is I replace the something, the trig function. If I replace that with a u, I get 2u squared minus 7u plus 6. Now that's a lot easier to look at and factor than have to deal with all the other stuff. So if I just deal with the factoring here, what's going to be first in both of these? 2u and u. Because you're going to multiply those two together to get 2u squared, right? Now, what's going to be true about my signs? Both negative, because I'm going to have to multiply these two to get positive 6 and somehow manipulate the addition to get negative 7. To multiply to get 6? 1 and 6, the problem is if I do 1 and 6, that's going to give me negative 1u and negative 12u. If I do 6 and 1, that's going to give me negative 6 and negative 2. Either way, I don't get negative 7. 2 and 3. So if I do 2 here, 3 here, negative 2 minus 6, again, doesn't work. 3 and 2. Negative 3u minus 4u, negative 7u. Now, honestly, there's multiple methods to do those. I don't care which one you use, but make sure you can actually get those factored out. Okay? Now, is that done factoring? What else do I have to do? Yeah, I substituted in u for the cosecant, so I need to put cosecant back in. So the actual answer for this is 2 cosecant of x minus 3 times cosecant of x minus 2. That's your actual factored form. Questions on that one? Okay. Now you might have ones like this you need to factor as well. What's the issue here? There's different trig functions going on. So I need to swap them out or swap something out so that I'm only dealing with one type of trig function. Does anybody see something I could swap there? Yeah, secant squared. How's that related to tangent?
1 plus tangent.
Right, 1 plus tangent squared is equal to secant squared. So I can take out secant squared and replace it with 1 plus tangent squared plus 3 times tangent plus 1. Simplify it out a little bit. I have tangent squared plus 3 tangent plus 2. Now this actually is fairly easy to factor because leading coefficient of 1. What do I have to multiply together to get tangent squared? Tangent. And multiply to get 2 to add up to be 3. You don't have a lot of options there. 2 and 1. So that would be your factored form of that polynomial, or trigonometric polynomial, however you want to say it. Questions so far?
No.
Okay. This one. Cosecant minus cosine times cotangent. Do I have a GCF I can take out? No. So the idea is I want to somehow manipulate this a different way. Now another option you have when you don't have anything you can take out whatsoever is because the nice thing about all the trig functions, they somehow relate to either sine or cosine using those reciprocal identities, right? Or the quotient ones. So I can actually always replace everything with sine and cosine. Sometimes that helps, sometimes it doesn't. If I do that in this case, the cosecant is going to become what?
1 over sine.
1 over sine. The cosine is just going to stay cosine. The cotangent becomes cosine over sine. Yep. Now I can clean that up a little bit by multiplying that through. So I have 1 over sine minus cosine squared over sine. You have the same denominator. Plug them together. 1 minus cosine squared over sine.
1 minus cosine.
Right? 1 minus cosine squared is sine squared over sine. Sine of t is your answer. Okay. These are honestly just puzzles. You're trying to use the right tools to solve them. Okay. Down here, perform the addition. In order to add these two together, well, it's adding together two fractions. What do you need to have? Common denominator. Now, 1 plus sine and 1 minus sine, right? Now, even though they have the same numbers, those plus and minus make a big difference because I can't combine them directly. It's honestly pretty much like trying to add 1/3 and 1/4. Your only option is to multiply by the opposite one. So the 1 minus sine I'm going to take times 1 plus sine over 1 plus sine. The 1 plus sine I'm going to take times 1 minus sine. Now the nice thing about these is these two things are what compared to each other? They're conjugates. So when I multiply the two conjugates together, the inside and outside part of the FOIL will cancel. So my denominator for both of them is just going to turn into what? 1 what? 1 minus sine squared. 1 times 1 is going to be 1. Negative sine times sine is going to give me negative sine squared. Negative 1 sine plus 1 sine goes away for the inside and outside. Now when I do the tops through, though, the nice thing there is you're just multiplying by 1. So all I need to do is basically copy those down as is. Now this one you don't really have to worry about it. Watch out on other ones like this if there's ever subtraction in the middle. So if this is subtraction, it's going to apply to both of these terms. Okay? If it's addition, it's no big deal, but if it's subtraction, you got to make sure to distribute the negative through the top. From there, what's my numerator going to turn into? 2. Because the negative sign and the sign go away. You get 2 over 1 minus sine squared, but what's 1 minus sine squared? Cosine squared. Now, this is still a fraction, though. I want to try to avoid that if possible. So, to get rid of the fraction, what would that look like? Well, what is it the same as when you have cosine on the bottom?
1 by 1 over.
Not by 1 over.
Or that over 1.
You don't have to multiply by anything. You can just swap this. 1 over cosine is the same as what?
secant.
Secant.
Yeah.
So 1 over cosine squared is secant squared. So this is just 2 secant squared theta. If you can avoid it, you want the thing as simple as possible. Okay? It is, but it's not quite considered simplest form. You want as few parentheses as possible, as few plus and minus signs as possible, as few division signs as possible, and a fraction is a division sign. Okay? Couple more. This one asks you to rewrite the statement so that it is not a fraction. Yeah, this one is really going to end up annoying you because a lot of these answers can be very ambiguous where you stop and as far as which state it's in. Okay? You're getting to the point in math where there's not one right answer, there's multiple right answers.
More chances to be correct.
Exactly. For this, rewrite the statement so that it is not in fractional form. I have cosine squared y over 1 minus sine y. Any ideas?
You could just write it as cosine squared y divided by 1 minus sine y, and then it's no longer in fractional
Yeah,
form.
division is still considered a fraction.
Cosine squared is equal to 1 minus sine squared.
Yeah, cosine squared is the same as 1 minus sine squared, right?
No, it's not sine squared.
And then the sine.
It's not quite, so I can't cancel things off directly.
Oh.
But what can I do with 1 minus sine squared?
1 plus sine times 1 minus.
I can factor it. 1 plus minus sine squared is the difference of two perfect squares. So that's 1 minus sine times 1 plus sine.
This actually is. And then you can't.
Now, because these are exactly the same, now I can cross them off. I can't just cross off sine on this because they're not exactly the same. I can't just cross off the ones because they're not exactly the same. If it's a monomial, no addition or subtraction, then you can do that. If it has any plus or minus, you can't. So your final answer is just 1 plus sine x. Okay. Y, whatever, yeah. The last couple of these, they make them look really weird, but they're not honestly too bad. This one wants you to use substitution to take x and replace it with 5 sine theta. It does limit theta to being in the first quadrant. And I want to write this as a trig function of theta. So I want theta in this thing. So all I'm going to do is take out the x, replace it with 5 sine theta. So I get the square root of 25 minus 5 sine theta squared. Now I want to clean this up though. What can I do to it?
Negative 5 sine theta squared.
I can't just move it out. Because the problem is the square root here, if there's a plus or minus in here, I can't apply the square root independently. It has to be applied to the whole thing at once. If, again, there's no plus or minus, then I can split it up. Then I can take the square root of the first part, the second part, third part, whatever. Marshall, what?
They're both squares, so separate out the squares. We get 25 is the square of 5.
No, the problem is this minus sign glitches that. I can't just separate it out. Okay? But what I can do is what? Square it. Get rid of the parentheses. Okay? If you're ever in doubt, try to remove some of the symbols that you can remove. And this is one of those things that depends how comfortable you are with your
Oh,
arithmetic manipulation.
okay.
Now what can I do with it?
The 25s.
What about them?
They like, because
They
25
cancel.
minus 25 is 0. So
No. Because this is like 25 minus 25x. They're not like terms. I can't just cross them out. I can factor 25 out though. Yep. If I take 25 out, it's still going to be under the radical. But what do I have left in the parentheses here? 1 minus sine squared. And what's 1 minus sine squared? So I have 25 times cosine squared. Now, because I got rid of all the plus and minus signs, 5 cosine theta. Okay.
what happened to when math was like
One more. And this is definitely a case of one that looks uglier than it is. Rewrite natural log of the absolute value of secant theta plus natural log of the cotangent of theta, or the absolute value of the cotangent of theta, as a single logarithm and then simplify. Yeah. Go ahead. Nothing? Okay.
You just multiply them together.
Multiply what together?
Secant times
Yeah, multiply together what's inside the two logarithms. You're adding up two logarithms, that means you can combine them together through multiplying what's inside of them. So when I do that, I'm just going to end up with secant times cotangent.
which cotangent is cosine over sine and secant. 1 over cosine?
Yep, secant's 1 over cosine.
Okay.
Cotangent is cosine over sine.
Oh, and then the cosine's cancel out.
Cosines are gone. You're left with the natural log of 1 over sine,
Which 1 over
cosecant.
sine is cosecant.
cosecant. So this would be natural log of the absolute value of cosecant theta. Now why would they put absolute value there?
Because you can't
Yeah, you can never take a log of a negative number.
Okay.
So it is just natural log of the absolute value of cosecant.
We're not even really
We reached that, we reached that limit now.
If you ever get it down to, honestly, most of the time the goal is going to be to get it down to either a single number or a single trig function. Okay? Sometimes you're not going to know exactly when to stop.
That's annoying.
Yes, it is. We'll do that a lot during this chapter, so you'll get used to it eventually.
No, we won't. No.
Okay, now, you have the rest of the time today to work on this stuff. This is bizarre enough that you do need to spend some time on it. Use it tomorrow. You'll have time to work on this as well.